people, welcome back to my channel. So in the last video we started with the semi-supervised learning in machine learning, and we saw some of the concepts and that were not into depth. So in today's video we'll see some of the terms that were discussed or that was meant to be discussed in this video. And one of the most important concept whenever you do SSL, which is not followed in other learning techniques, whether it's supervised or unsupervised, that is something called as safeness, or something you called as the safe SSL. So let's understand. So before we go into this topic, let's understand what the SSL learning or how the training process is basically done. So what we have, so whenever we do training or to build a machine learning model, whether it's your normal supervised or whether it's unsupervised, that's a clustering process. But let's stick on to the SSL, that is semi-supervised as well as the supervised learning. What happens is, like, we have some set of instances, right? So some instances. Now in case of semi-supervised, since it uses both the labeled as well as the unlabeled, we'll have both, that is label and unlabeled instances. Okay, so labeled instances, let's take a scenario like you have taken 20% and 80% you have the unlabeled data. Usually this is followed in general, because labels, you know, like it's very difficult to obtain, but unlabeled it's available freely, or it's not that difficult to obtain. Now usually in the supervised learning scenario, what we do is we take the instances. So these are the instances that we feed to our SSL algorithm, whatever it be, say S3VM or semi-supervised Gaussian mixture models or any graph based SSL techniques, any of them, we feed these to these algorithms. And let's talk about what happens in the normal supervised scenario. So you train your machine learning model and then you try to predict on the future instances which are unseen on the test set or on the validation set accordingly. So you try to predict the labels or the classes on the unseen data, and you get some accuracy for the new instances that you encounter. But this story is somewhat different when it comes to the SSL. So here you don't have one goal, but you have two different goals. So the first goal remains the same, that is predict on the unseen data. That is one goal. And second is to predict the labels on the unlabeled instances in the training data. So I hope you get the problem that what we are trying to find. The first one remains a simple, that is the usual supervised scenario. But here, since we are also using some proportion or a majority of the portion of the unlabeled instances, we would also be required to find what would be the labels of this particular set or this proportion, so that later in a next iteration, when we have even more labeled instances, or the proportion of this may be 30 or this would be 70, say for example, we'll get even more good predictive power, something like that. So our goals are these two, or whenever we try to find some instances or the labels, we'll have these two things to keep in mind, and then we'll do the kind of prediction. So we have been doing these things so far. So there in the previous video I said there are two types of learnings that are followed in general in semi-supervised learning. Those are inductive approach. So this one, the former one, is called as the inductive learning. That is the usual cases that we have been doing so far in the supervised techniques, decision trees, knife Bayes, linear SVMs and so on. This thing where you try to predict the labels on the unlabeled in the training set are called as the transductive learning. So it is not that difficult, it's very simple, but whenever you implement this, so then you have to keep certain things in mind about the data quality or the assumptions that is followed by the underlying models, whatever you are trying to use. So whenever you have transductive learning, you will use something called as the S3VM. So that is meant to behave in a transductive style. And when you use an inductive technique, you can use SSGM algorithms like that. So this is the story, or this is a goal that I would like you to know what is behind SSL. Now, so let's now focus on to what this safe SSL thing is. So for that, I want to give you a problem scenario. Say we are trying to solve a problem use case. So I'll give you a use case, a problem description. Say we want to do image classification. So basically then the first question would be asking is why to go with SSL. It's a hectic process, rather to use deep learning techniques. We'll see the benefits of using what the SSL, or why we want to use SSL for image classification. So the use case is like we want to do image classification and there are 9,000 images. So image, say if you take the image of any scenery outside also, you can see there are people, there are trees, there are mountains, there are other things like transportation, etc, etc. So it's not the image is consisted just only one image, but there are many subsets of the image within that. Okay, so first, once we have this 9,000 images, we want to extract individual images out of this also. So for that we have certain encoding techniques, DFT, zigzag transformation, stuffs like that. So we may want to apply those things, and say for example, after extraction those individual images, we'll have say 15,000 images in total out of the all images individual extracted from within the image. And also a special case that we would be taking care into account is something called as a Dorster effect. You can find the image here. So what the Dorster looks like, or what it's meant to be. So once on this we have extracted this many images, so we no longer would be requiring this, but it's an elevated kind of instances, or the data now it's become a little big so that it can be used for our training purposes. Now with a 80-20 or a 20-80 partition, what we have, so if we do a 20-80 split, say 3,000 of the images which are labeled goes to the labeled set, and which are unlabeled, rest 80 goes to the unlabeled set. So the thing is that I just want to make you focus over here, that is 20-80, that is a general rule. So once you do this, you get some accuracy, you build your model. Later you solve these two goals. At this point of time, you get the labels for the instances in the training set. You later change this, say 35-65, you do the iteration again and again until you obtain a certain accuracy. Now when do you want to stop this thing? So that is a very crucial thing, because if you do only one iteration and get an accuracy, say 65% or 75%, and if you think, okay, after doing all this big hurdles I got a accuracy of 78% or 75%, that's not the story, wait there. So the thing is like, you have to compare with the existing techniques which is implemented, whether it be deep learning techniques or your supervised learning techniques with some SVM or some other decision trees or naive Bayes. And first you have to look that what is the accuracy of those techniques by using the supervised techniques, or with the label techniques, how much it is. Say for this setting only, say let's not apply any supervised, but let's apply deep learning techniques, and say for deep learning technique we get a accuracy of 98%. That is very overhyped. Say let's take 91% accuracy for by using the deep learning technique. And with the same approach, you get a nearby comparison of say 89%, okay, with the SSL. Then we can say that it's okay, because that is deep learning techniques. It will use some kind of other hidden layers, and it will have more weights, more parameters to tune stuffs there. So here we don't have that much liberty of building a neural network. So there we get if an accuracy of 89% at least is obtained here in this case, then also it would be good. But on the contrary, if you are solving some other kind of problem with the SSL, and if say in supervised technique, and if we got 90% and the same thing with SSL for a different problem, if we are getting something like 78%, because it's not nearby to comparison of the supervised learning technique, there your SSL technique would fail, because it is not called as statistically significant. So something called as statistically significant comes whenever you do the safe SSL, or what the safe thing in safe SSL means is that the performance of the SSL technique should not be statistically significantly worse than those of the existing supervised techniques. That means that in the supervised technique, if you are getting 90% accuracy, and by using SSL technique, if you obtain greater than or equal to 90%, then you accept that. So there your SSL technique is meant to be safe. Else if it is not the case, and if it is getting 78% or even less than that, 35% or 50%, in some cases this happens, then in that case there would be no point in doing your SSL learning at all, because that is not nearby comparable. Also you can see a graph here. I'll put this image. You can see somewhere here an image how the performance is changed over a period of time, and in this case we can say that your SSL technique is not good, or it did not perform in a better way as compared to the normal supervised techniques. So why to do this safeness of SSL? Because whenever you have this unlabeled instances, because you use that for your training, right? So there will be many kind of errors in that. So there may be some kind of data quality issues or misleading data, or even the annotator mistakes that you have to take in mind, or certain uncertainty in the data. Whenever you fetch from a data pool, inconsistencies might happen, so that can also lead to some inaccurate results whenever you do the prediction or somewhere. So you have to follow not a safe SSL, but a complete safe SSL pipeline throughout the entire process. So here it's a diagram that it depicts safeness of SSL pipeline in data science whenever you do this kind of techniques, because it's not all about taking the partitions or splitting into multiple iterations and then running, but then to follow this kind of steps very carefully, so that you don't arrive at an misleading result, or you are not under a wrong impression that you have done SSL in a correct way. So only once you do the safe SSL in a proper way, you can then state that whatever accuracy scores that you are getting is okay, or to be compared with the existing techniques, or which has been already implemented. So well, that was all regarding concept of the safe SSL in machine learning. So hope you guys enjoyed this video. If you found this video helpful, please do like, share, comment, and if you are new to this channel, please consider subscribing. Thanks a lot for your attention.